do another example from 1.5, another application problem, number 25, which is right here. Before we begin this example, I want to review the Pythagorean theorem. If you remember, the Pythagorean theorem is dealing with a right triangle. A right triangle is a triangle with a right angle, which means it's 90 degrees. The Pythagorean theorem tells us that the length of a leg squared plus the other leg squared is equal to the hypotenuse squared. And remember, the hypotenuse is the longest leg on a right triangle, and it's also opposite the right angle. Okay, now that we know that information, if you look below here on the picture, there's actually a right triangle on this picture right here. It's very hard to read, but it's actually there. Okay, so let's kind of read through this example here. It says a hot air balloon rises straight up from the ground at a rate of 120 feet per minute. So every minute it goes up 120 feet. The balloon is tracked from the rangefinder on the ground at point P, that's right here, which is 400 feet from the release of the balloon, which is point Q. Okay, so right here, I don't know how you can read it, but this distance right here is 400 feet. Okay. Let D be the distance from the balloon to the rangefinder. That's this distance right here from the rangefinder to the balloon. And let T be time. So I'm going to say T is time. And again, it says in minutes. I should write that down. Express D as a function of T. Okay, so what we need to do is we need to look at this part right here. It says 120 T. Let's explain that a little bit further. Every minute, it rises 120 feet. That's what this rate tells us. Every minute rises 120 feet. So if T is time, this length right here is 120 T. Okay, using the Pythagorean theorem, I'm going to take this leg and square it. Plus this leg and square it. And that should be equal to the hypotenuse, because it's a right angle here, squared. Okay, so what I'm going to do is I'm going to go ahead and solve for D. Keep in mind that all these numbers must be positive, so the answer must be positive. Okay, so if I go ahead and solve this, I get D squared is equal to 14,400 T squared plus 160,000. Okay, now if I want to solve for D, what do you normally do? Say D is equal to plus or minus, but we know that this distance cannot be negative, so we're only going to include the positive square root. So again, normally put plus or minus, but we know distance cannot be negative, so we cannot include the negative in our answer. So I'm just going to go ahead and erase that negative there. Okay. Oops, I forgot a number there, didn't I? Let me go back here. There we go. Okay, so D as a function of T would be equal to what we have above in the radical. And since it is distance, it would be, the answer would be in feet, of course, since the time is in minutes. Okay, so that includes the application problems for section 1.5.